Hey guys, it's Mr. Schwartz. Just wanted to show you how to use another factoring technique. It's called factoring perfect square trinomials. This is a part of our master factor plan that we would implement. When we try to count the number of terms, you see there's 3 terms, which means it's a trinomial. It could be a perfect square trinomial. So we're going to take a look at that today, and I'm going to show you how to first identify what a perfect square trinomial looks like, and then how to factor it. If we review a typical problem here where we're squaring a binomial, okay, and we go to expand this, we would see that we end up with the first squared, x being the first. So x squared would give us x squared. We would multiply the first term times the second term and then double that, which would give us 4x. And then we would square the second term, which would give us 4. Okay, this actually, when we square a binomial, this gives us what's known as a perfect square trinomial. And keep in mind, when we're factoring, we're looking for the things that are being multiplied. So we're actually going in this direction. So we're going to be given the PST, and we're going to be asked to come up with the factor, which would be this binomial squared. Okay, so how do we identify it? Well, the first must be a perfect square. The last must be a perfect square, which it is, of 2. The first is a perfect square of x. X times x is x squared. 2 times 2 is 4. And then 2 times x doubled has to be the middle term. And if all those check out, this would be a PST. And if this is a PST, then we can factor it as a binomial squared. It would be the square root of the first, x, the square root of x squared is x, the square root of the last, and then it would be that binomial squared. Okay, let's take a look at another one over here, number 2. All right, again, if we were given this problem, we know that this is asking for us to square this binomial. So we would square the first. Keep in mind, we're not just squaring the x, we're squaring the 3 and the x. So that would become 9x squared. It would be the first term times the second, and then we double it, which would give us negative 24x. And then it would be the second squared, which would give us 16. Okay, again, when we square a binomial, this creates a PST. We won't know that if we're looking at this trinomial, so we got to check it. Is the first a perfect square? And hopefully at home you guys are saying yes. 9x squared is a perfect square of 3x times 3x. Is the last a perfect square? And that's pretty easy to see. That would be 4. 4 times 3x is 12x. If I double that, do I get 24x? So this indeed is a PST, and we could factor it going in this direction by taking the square root of the first, which is 3x, the square root of the last, which is 4, and just keep in mind these signs. Minus and a plus will give us a negative when we factor, and then when we saw here is a positive and a positive, it gave us a positive when we factored, okay? So this is the technique that we'd be using. This is called perfect square factoring perfect square trinomials, and we're going to look at some more examples down below here in your math notes. Now, if you need a copy of these math notes, you can go onto Google Classroom and you can copy this using a printer, or you could just follow it along and make sure you're learning how to do what we're trying to do here, which is factor these PSTs. Okay, so taking a look at number 1, of course, this looks like a type 1 trinomial, and indeed it is, but we could factor this using this technique, because the first is a perfect square of x, the last is a perfect square of 7. 7 times x doubled is 14x, so we can go straight to a binomial squared. Okay, so x squared, the square root of x squared is x, the square root of 49 is 7, and the sign combination means there must be a plus in between. Okay, so that would be the quantity x plus 7 squared. That would be the factor. This tells us that there's 2 of them. So there's really 2 factors, or 1 depending on how you look at it. X plus 7 times x plus 7. Okay, we'll keep cruising here. Again, we notice this is a perfect square trinomial. This is a perfect square of x. This is a perfect square of 8. x times 8 times doubled would be 16x. So this could be factored as a binomial squared, which would be x, watch the signs, minus 8. Okay, keep cruising here. Now if we look at this guy, this looks a little different. Okay, there's more than one variable in it, but we've seen this pattern before. X squared on one end, y squared on the other end, and x and y in the middle. Well, all that means is we're going to try to factor this as a PST, but instead of just having one variable, we're going to add another one in at the end. Well, is 4x squared a perfect squared? Sure is. 2x. Is y squared a perfect square? Yep, of y. 2x times y doubled gives us this. So we take the square root of 4x squared, which is 2x. We take the square root of of y squared, which is y. I look at the sign combination. This tells me it's going to be a minus, and I'm done. So you could tell this is a very efficient method. It's not very difficult, a lot of work, but the key here is to be able to identify, are these PSTs? Okay, that is the key here. All right, and I could see clearly there's 3 terms on this one. This is a perfect square of 5x. This is a perfect square of 3. 5x times 3 is 15. When I double it, I get 30. Now, if you double it and you don't get that middle term, that doesn't mean that it's not factorable. That just means that it's not a PST and you can't use this technique. All right? We would have to try to factor it using one of the other methods. But since this is a PST, I can set it up. 5x squared, 25x squared is 5x. The square root of that is 5x. The square root of 9 is 3. And the sign combination means this would be a plus here. Okay? One more. I'll give you a second if you want to give it a shot. Just make sure it's a PST. If it's not, we wouldn't be able to use this technique again. And this does look like it's a PST. So we're going to factor this down to a binomial squared. 16m squared, that is a perfect square of 4m. 25n squared is a perfect square of 5n. And this sign combination would be as such. Okay? And it's that easy. It's how you would factor perfect square trinomials. Okay? We could see where it comes from. Keep in mind, the way we showed it is by multiplication, and when we're factoring, we're finding the things that are being multiplied, okay? That's the idea there, finding the things that are being multiplied. All right, so that's a quick lesson just to get you guys going again. Tomorrow we're going to work on factoring difference of squares, and we'll have another short video and then some homework along with that. All right, good luck. I think you guys will be fine with this, and we'll keep cruising here. Keep it up. See ya.